All right, so like I said earlier, section 4.1 and 4.2 are basically, they're all the same topic. They're basically one section. So we're just going to do them together, 4.1 and 4.2. They both, what we're going to deal with is the idea of negative exponents. So the first 15 minutes of what we talk about is me reviewing. This is stuff that we assume you know coming in intermediate algebra, but I don't always like to assume. So I'm going to just do a real quick review of the properties of exponents that hopefully you already know. Like I say often, if this is not knowledge for you, if this is brand new, email me or see me after class. I have some resources that can be helpful in getting you up to speed. So we're going to talk about the 3 properties of exponents. And again, I'm hoping that this is stuff you recognize. So the first of our properties of exponents is called the product rule. The product rule. It tells us what to do when we multiply 2 things together. So for instance, here's a pretty typical example. If I have x to the 7th times x to the 4th, notice I'm multiplying. That's what the dot means. Some specifics about this. When you apply the product rule, the base has to be the same. If the bases are different, there's nothing you can do here. Does anyone remember what the product rule tells me? What do I do with the exponents when I am multiplying my bases together? You add them. So x, the base does not change. It stays x. And then what is my new exponent going to be? 7 plus 4 is 11. Fantastic. Okay. Again, I'm hoping that this is review, but if it's not, I can be helpful. Let me know. So I've got 5 examples I'm going to write on the board. There's a different thing I want to highlight from each example, but I just want you to work them and see how much you remember. So here's the first example. It's y to the 3rd times y to the 9th times y to the 6th. Example 2, 8 to the 4th times 8 to the 5th. Example 3, x times x to the 7th. Example 4, p to the 5th times q to the 2nd. And then the last example is this. I've got a squared b to the 5th. And then I've got a to the 3rd, b to the 6th. I'm going to give you a couple minutes to sort through. Remember, if you don't quite get something, that's okay. We're recollecting, we're learning. Yes. Which one? This is p to the 5th, q to the 2nd. Yes, none of my elementary school teachers like my penmanship here. All right, so if you're still working, keep working. If you get something different and you do not understand why, please ask. That's why I'm going through the effort of reviewing this, okay? I know this. I don't need to review it. I'm doing this for you. I want to be helpful. Okay, so my purpose in this first example is just to remind you that the product rule applies no matter how many bases you have. So I have 3 bases, y times y times y. My result is going to be y. And then I just add the exponents. So 3 and 9 is 12. 12 and 6 is 18. So we have y to the 18th power. Okay, so far so good? Anything we need to talk about? My purpose in this second example, probably the most common mistake. In all honesty, most students in this class, when you take this test, you're probably going to do really good on this part of negative exponents and using the properties, but this is a common mistake. My base is 8. What's the base of my answer going to be? Okay, I'm glad we're talking about this. Okay, when you apply the product rule, the base does not change. Okay, adding the exponents is what takes care of everything. So 8, 8, my answer has an 8. Okay, the base does not change. Okay, I know probably half of you did that. Okay, that's why I make this my example. And then 4 plus 5 is 9, 8 to the 9th power. So if you wrote down 64, learn from that experience, because I'm going to put a couple of these on the test. I don't want you to make that mistake then. Okay, that's why we're reviewing. This next one, just want to remind you, when you see a base that doesn't appear to have an exponent, what is its implied exponent? Okay, a 1, you can write that 1 in to remind yourself. It's a good habit. And so that is x to the 8th power, 1 plus 7. This next example is just to make sure you heard me a moment ago. The product rule only applies when the bases are the same. So can I do anything with this? No. So if you wrote down something to the 7th power, erase it. Okay, there's nothing I can do with this. Okay, so it's done. It's simplified already. The last one, I just wanted to highlight the fact that when I have multiple bases and I'm multiplying, okay, notice there's no addition here, there's no subtraction, it's all multiplying. And so what we do is we consider the a's by themselves and the b's by themselves. So I have a to the 2nd, a to the 3rd. How many a's is that? Yep. I have b to the 5th, b to the 6th. How many b's is that? 11. Great. All right, before I move on from the product rule, that's the first of the 3 rules of exponents. Any questions about that? Yeah. Okay, so that's a great question. On the test, I will not care. My math lab, when it's a smaller thing, you just pop it in the calculator. But for something big like this, I don't even think they'd want it then. If you don't know how to do exponents on your calculator, let me know. If everyone in here, I'm guessing, probably has either a Texas Instruments calculator or a Casio calculator. If you have about half of the Texas Instruments calculator have a button that looks like this. It's called a caret. Okay, it's the math symbol that's sometimes used for exponent. So if you wanted to evaluate this on your calculator, you would do an 8, then you'd hit that button, then you'd hit the number 9, and then hit the equals, and it'll tell you something very large. Okay. If you have the other half of the TIs or a Casio calculator, you have a button that looks like this. You have an X with a Y button. It's an exponent button. You'd hit the same keys. You hit the 8, then you hit this button right here, then you hit the 9. Some of the calculators you have to hit the equals, others of them you don't, and it's going to give you that large number. So if you can't find that button on your calculator, be good to know that before the test. So just see me after class. Take us 4 seconds to find it and highlight using it. Okay, great, good questions. Love it that you're interacting. That's the product rule. All right, the next one. This is the second of the 3 rules for exponents, called the quotient rule. In case you're not familiar with it, quotient is just a fancy math word for division. So the product rule dealt with multiplication. Quotient rule deals with division. So here's my quick and clean little example. If I have x to the 9th divided by x to the 3rd. Again, notice bases are the same. Quotient rule only applies when the bases are the same. I'm sure you remember this. Hopefully all of this is flooding back, maybe some bad math memories. What do you do with the exponents when you divide the bases? Subtract. Fantastic. So my base stays the same. It stays x. And then 9 minus 3 is 6. There we go. So I've got 3 examples just to highlight some things about the quotient rule. If you have any questions about the quotient rule, please bring them on. Love questions. So you've got t to the 8th divided by t to the 2nd power, and then 3 to the 17th divided by 3 to the 5th. And then the last one that I have for us is x to the 7th, y to the 5th divided by x, y to the 3rd. You okay? Sure? Okay. All right, quotient rule. T to the eighth divided by t to the second leaves me what? Okay, the base stays the same. 8 minus 2 is 6. So far, so good. Does anyone have any question at all about what's going on? Same thing here as with the product rule. Be careful with your bases. 3 to the 17th divided by 3 to the 5th. What do you think the base of the answer is going to be? Yes, excellent. Okay, don't cancel it out. Doing the quotient rule, subtracting the exponents takes care of all the arithmetic. And then 17 minus 5 is 12. That's going to be a very large number. I'm going to leave it like that. And then here, same thing as I mentioned before, the product rule, different bases, consider them separately. So I have x to the 7th divided by x to the 1st, x to the 6th, y to the 5th divided by y to the 3rd, y to the 2nd. Yeah. So what if you have a large number on 5? That is a beautiful question. Give me 5 minutes and I'll make all your dreams come true, okay? I promise. So if you didn't hear, the question was, what if the number on the bottom is larger? I love that question. I can't wait to answer it. That's really why we've gathered today. So that's going to be the culmination of our review. You okay?
I'm just asking if the bases can be the same for the quotient rule.
Yes, bases, both t's, both 3's. And so then here, we considered the x's and the y's alone. We can't do anything, can't cross over. So if I had given this problem, if I said, what's x to the 5th divided by y to the 4th? There's nothing I can do with that, okay? No quotient rule because the bases are different. Great question. Okay. All right, great. Don't be shy with me. The last of the 3 basic rules. So product rule, what do we do when we multiply the bases? Well, we add the exponents. Quotient rule, what do we do when we divide the bases? We subtract them. The last one is called power rule. Power rule tells us what to do when we have a power raised directly to another power. So for instance, if I have x to the 7th, and then that is being raised to the 3rd power. So a power raised directly to another power. Anybody have a thought on what I'm going to do in this situation with the exponents? You're going to multiply it, right? You got a power raised directly to another power. So this is going to be, again, we don't change the base at all. It stays the same. And then 7 times 3 is 21. So here is 3 power rule problems. Actually, I'm just going to give you 2 of them. And then I'm going to give another one because there's something that I'm expecting. It's another one of those things that's commonly missed. So here we go. Here's your first one. X to the 5th raised to the 6th power. Go for that. And then 3, x to the 2nd, y to the 3rd, all of that raised to the 4th power. All right, x to the 5th raised to the 6th is what? Perfect. Okay. Now this one, there's something that I'm guessing probably about half of you missed. Again, if you missed it, don't beat yourself up. Don't shame yourself. Learn from this situation. I am guessing that most or many of you wrote this down as the answer. 3, x to the 8th, y to the 12th. Okay, that's one of the common things I see. Here's the problem. What's the power on the 3 right now? What was that? Yeah, it has a 1, right? Everything has its own power. So the 3 has a 3 to the 1st. We have to apply the power rule to that as well. Okay, so don't overlook the coefficient when you're doing the power rule. Super common mistake. That's why we're doing the review. So the 3 is really 3 to the 1st raised to the 4th, so it should be 3 to the 4th power is what you should have there. Now, again, I'm going to repeat this. I, on the test, love this. You can be done and move on to the next problem. I believe my math lab is going to want you to multiply this out. So you're going to do 3 to the 4th, and you're going to get 81, x to the 8th, y to the 12th. So I'm going to just write up real quick 2 more problems because I just want to give you a chance to redeem yourself on that in case you wrote down the first answer. So here's the next one. I want you to do 5. Let's do 5a to the 6th power, and we're raising that whole thing to the 4th. And then I want you to do 2x squared over y to the 8th, the entire thing raised to the 3rd power. All right, the first one. Okay, so again, when you see this, when you're asked to do the power rule, my recommendation to remind yourself is write a little 1 on the 5 so you remember it has its own power. So when I apply the power rule to this, what am I going to have? 5 to the 4th, a to the 24th. I'm going to leave it like that, but if you wrote 5 to the 4th is 625, that's great too. This one, I just wanted to give you a power rule problem that had a numerator and denominator, just so you see that it doesn't change anything. So again, I'm going to write a little 1 on my 2. So hopefully you wrote down 2 to the 3rd or 8 right there. X to the 6th power divided by y to the 24th power. And again, these bases are not the same. The quotient rule does not apply. We are done. Yeah. But I didn't, that is a great question. In case you didn't hear it, she asked, I thought when you were dividing, you were supposed to subtract, but I have not divided anything. I'm applying this power of 3 to everything inside the parentheses. So that's the power rule. If these have the same base, then I would be dividing. Okay, so I've not actually performed division here. Yes?
Even on math, like if you put like 8x to the 6th power, I guess that's right. Or like what is the correct either way?
I am 96% sure that on my math lab, you have to put 8. Okay, so I think they want you to multiply this out.
So if that other 4% is wrong, I'll still leave it at 1%.
I'm just saying, be cautious. The first time you do one, if you put it in like this and you get it wrong, then you know. I'm pretty sure they tell you in the instructions, but just in case they don't. But again, on the test, I'm great with this. Okay, you don't need to do more work. I know your calculator knows what 2 to the 3rd is, so I'm good with it from there. Okay, yeah.
So what if they correct?
Okay, so this will answer yours, also answer your question as well. 2x to the 8th. Now, at this point, when we learn we're 90 seconds away now. When we learn what to do in this situation where the power in the denominator is bigger, you have a choice of 2 things. You could divide right now. Okay, you could do that first and do the quotient rule. Or you can do the power rule and you could say 2x to the 6th over x to the 24th. And I'm going to put a pin in this. We will come back when I tell you what to do when the power in the bottom's more. Okay, so we will do this. The base is the same. I can now apply the quotient rule. Okay, so pause. Before we get to that, I know you guys are super excited. I love it. One more little thing, bit of trivia. Power of 0. So for instance, if I have 16 raised to the 0 power, again, this is part of my review. I know what some of you are going to say. What is any number raised to the 0 power? What's that going to be? Okay, I've heard 2 things, okay, and I expected both of them. Okay, we are not multiplying these things together, so the answer is not 0. Okay, so if you said 0, that's okay, I understand, that's why we're here. Unlearn that. Anything raised to the 0 power is 1. So on the test, when I give you this question, and I will, I promise, these are free points if you're just awake today. Okay, if I give you 1,254 raised to the 0 power, what is that going to be equal to? Okay, 1. And please put that in the memory banks. Anything to the 0 power is 1, and you can move on. All right. So at long last, I had sound effects. We have a drum roll going on, but we're going to go back to the quotient rule, and we're going to answer this question right here that has been hazarded to me. Let's say that I have x to the 4th divided by x to the 7th. Now the power on the bottom. This is the new bit. All that we've done up to this point, that first 15 minutes, I'm anticipating that was review. So like I said, if that's not review, let's talk. Okay. This is the part now that I'm assuming you might not know. So this is the quotient rule. So let's just apply the quotient rule. Okay, why shouldn't that apply? So here we go. Quotient rule says when I am dividing the bases, what do I do with my exponents? Subtract. And so when I go into my calculator and I say 4 minus 7, what's 4 minus 7? Negative 3. Okay, so far we're good. But that raises the question, what in the world does a negative exponent mean? Okay, what value would I give for that? How would I put that into my calculator? So what we're going to do, so that I can show you what this is telling us, we're going to evaluate this another way. So here it goes. We're just going to go back to what exponents mean. X to the 4th, what x to the 4th means is I have x times x times x times x. I got 4 of them, right? We all agree with that? That's what exponents mean? Yes, thank you for still being awake. I appreciate it. X to the 7th in the bottom. How many x's am I going to multiply together now? 7, yes. 1, 2, 3, 4, 5, 6, 7. Okay, so now I got things in the top and the bottom that are the same, so I can do some canceling. How many x's can I cancel in both the numerator and denominator? They both have 4 in common, right? So I'm just going to do that. So there's 1, there's 2, there's 3, there's 4. How many x's are left? Here's the key question. Where are those 3 x's? On the bottom. Ah, okay. So the result here is I've got nothing left in the top. I've canceled everything. So I've got 1 left. In the bottom, I've got x, 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 x to the 3rd. That's what the negative exponent is telling you. The negative exponent is telling you the position of the base. Negative exponents are positional. It's telling you that your base is in the wrong place. So when you see a negative exponent, x to the negative 3rd, your last step on any problem is you are going to then say, oh, that's 1 over x to the 3rd. This is telling me, that negative exponent is telling me that I need to put the base in the bottom. And as an aside, when I give you the problem in a minute, if the negative exponent's in the bottom, you're going to throw it up to the top. Okay, it's in the wrong place. So here is the general rule right here. The general rule is this. These are the letters our book uses. If I have any base, A stands for any base, to the negative number, so negative n power, that is always, every time, 100% equal to 1 over a to the positive n. So this is the new bit of information that we are going to spend the rest of our time today practicing. That new bit right there. This is what we do with negative exponents. And that's why we're here today. So here's what I'm going to do. I have 1, 2, 3, 4, 5. I have 5 problems that I'm going to give, and that the only thing I'm asking you to do is to resolve the negative exponent. I don't expect you to do anything other than that. So, oh no, I have 6 problems. There we go. I got 6 problems for you. I don't expect you to do anything other than resolve the negative exponents. Then we'll go over to, and we'll finish that problem where the question was, what would have happened if I could have applied the quotient rule and I have the bases that are the same. And so here goes. So take a look at these problems and just use that little rule right there. I got a couple problems here that I have a specific reason I'm asking them so that we can have some learning. So first one, nice and straightforward, y to the negative 6. The next one, 5 to the negative 2. Then this one, this next one, I've got x to the negative 3. and y to the 5th. Be careful on that one. Which one's got the negative exponent? 3p to the negative 2, 1 over y to the negative 7, and then the last one, a to the negative 3rd over b to the negative 7th. Give you a minute or two to chew on all those. All right, so remember, we are learning here. I'm expecting this to be new to most of you, if not all of you. So if you missed any of these, that's okay. It gives you an opportunity to learn what's going on. So the y to the negative 6, this is just the straightforward rule for negative exponents. What do I change that into? 1 over y to the positive 6. Notice I changed the sign. It's no longer a negative exponent when I put it in the proper place. Are we so far so good? 5 to the negative 2. Again, this is a pretty straightforward problem. According to the rule for negative exponents, I'm going to change this into what? 1 over 5 to the 2nd. I changed the exponent. And then, yes, if you said 5 to the 2nd, that's 25. It's 1 over 25. You don't do any evaluating. You do not do any evaluating with the exponent negative. Sometimes students, and you may have written this down, and I totally get it, you may have written down negative 25 here. That's wrong. Do not evaluate an exponent. First off, the negative exponent does not make anything negative. It has no relationship. Okay, so that's why that would be wrong. The first thing, you do not evaluate until you've put the base in the proper place. So keep that in mind. If any of you did that, that's okay. Just cross out, make a little note to yourself. Don't evaluate until you've put the base in the right place. Okay, the reason I give this next problem right here is I just want to remind you that each each factor gets its own exponent. Which one of those has the negative exponent, the x or the y? The x. Okay, so here's what you're going to do. If you didn't do this, that's okay. This is new and different. I'm going to put a fraction bar. The x to the negative 3rd. Where's the x to the negative 3rd going to go? Goes on the bottom, becomes x to the 3rd. Does the y to the 5th, does that have a negative exponent? Do I need to move that anywhere? Nope, it stays right there on the top, y to the 5th. It doesn't go anywhere. So if you didn't know that, that's okay. You're going to get more opportunity today to change that. Yes? Okay, so we'll get to that. If this is another x, we'll talk about how to simplify that. Okay, all of what we're going to see after we've practiced the rule for negative exponents, then what we're going to do is all of those properties we just reviewed, those 3 properties, the product rule, the quotient rule, the power rule, they all apply with the negative exponents. There's no difference. The only difference is when your final answer turns out to have a negative exponent, you got to resolve that. Okay, that's the only new thing. So we'll get there. This next one is like the previous one. What's the exponent on the 3? A 1. There's no parentheses around it. Those things are not grouped together. The exponent on the 3 is a 1. So which one of those factors do I move to the denominator? P to the negative 2 goes to the bottom, becomes p squared. The 3 is its own thing. It's up top. So again, we're just going through common things that I see done. There's no parentheses around this, so you don't move both the 3 and the p to the bottom. If you saw this, hey, this is just an aside. If I had given you this problem, 3p with parentheses around it, now what is this -2 power? What's it applying to? The whole thing. So you would, yes, in that situation, you'd move the whole thing to the bottom and you'd get 1 over 3p squared. Okay, different things. Parentheses have meaning. All right, I prepared you beforehand, but again, maybe you missed it because I say a lot of things that are meaningless. Why to the -7, but it's in the denominator? So how do I resolve that negative exponent? Where does it go? Goes to the top and becomes y to the +7. And I don't write it over 1 because anything over 1 is just, it's the thing. And then again, this is just another instance of that. Okay, so I've got a negative exponent in the top, a negative exponent in the bottom. So the a to the -3, where am I going to put the a to the -3? In the bottom, it becomes a to the 3rd. The b to the -2 is in the bottom. Where am I going to put it? Up top. There we go. Okay, so that's the new bit of information for the day. Before I move on, I don't want to rush away from this. Anybody have a question that I did not answer, or is there something bothering you about these negative exponent problems? Yes. Yeah, and that one's not done. Yeah, you're exactly right. Then you'd apply the power rule, and it'd be 3 squared p squared, 9p squared if you want. Yes. Yep. Wherever you see the negative exponent, it's a great summary. Wherever you see the negative exponent, it's telling you that that base is in the wrong part. So if it's a negative exponent in the bottom, you throw it up top. If it's a negative exponent in the numerator, you throw it down the bottom. Okay, it's always the situation. Okay, great summary. Any other questions? All right, since that problem is still sitting there, let's finish that up. And then I've got a bunch of problems for you, just now combining those 3 rules that we have reviewed with this new thing of negative exponents. So back to this, if you remember, my original problem had a y down here, and since the bases were different, we didn't have to do anything else. But then I got asked by a couple different people, what if the base was the same? This is great, I love it. So if the base was the same, here might be my next step. I'd apply the quotient rule now, and I'd have 2 to the 3rd, and then I'd have x to the, well, what's 6 minus 24? -18. Your calculator will tell you that. Don't be shy. Use your calculator. And so now, just like we saw in all the problems that I just erased, sorry, I'm regretting that now. Here's my fraction bar. The 2 to the 3rd. Where am I going to write the 2 to the 3rd? Top. It stays in the top. The exponent's positive. And I know it's probably bothering some of you. 2 to the 3rd. 2 times 2 times 2. 8. And then x to the -18th. Becomes x to the 18th on the bottom. There you go. That's how you finish that problem if the bases were the same. And that's exactly where we're going right now. We're going to have problems that bases are the same and you're going to have to simplify. So we're just going to go one at a time. All we're doing here is those 3 properties we just reviewed and spent 15 minutes doing. We're just applying them in this new situation. So here's a first problem for you. I'm going to give you 30 seconds. If I give you x to the 5th times x to the -9th. Use the product rule. Any question or? What does the product rule say to do when I multiply the bases? You add them. So again, your calculator. What does your calculator say when you have 5 plus -9? That is what? -4. The only new step Okay, that's part of our review. Hopefully that looks familiar. The new step is, oh, I got a negative exponent. What does x to the negative 4 mean? There you go, required step, done, simplified. Here's your next one, same sort of thing. Just going through a bunch of problems. Stop me when you need to. X to the negative 8 times x to the 4th. So again, same problem, it's product rule, you add them. So use your calculator freely. Negative 8 plus 1 is negative 7. Negative 7 plus 4 gives me x to the negative 3. And then once again, x to the negative 3, what does that mean? Are we doing okay so far? And we're just applying those rules that we talked about a few minutes ago with now negative exponents. Again, being super upfront and honest with you. I don't think that's going to cause any of you a problem on the test. Here's the problems that's going to cause a little bit of an issue. Be super, super careful when you're subtracting with negative exponents. Okay? I'm going to give you some quotient rule problems. We're going to get to make sure we can iron out any issues. So here's your first one. 5 to the 4th divided by 5 to the negative 3rd. Be real careful when you are subtracting and you have negative exponents. All right, so I'm going to start writing this down. Check your work with mine. So the quotient rule says I'm going to subtract these exponents. I'm going to write this out for you, just in case you made a mistake. So we have 5. The base does not change. Remember that. And then what's the exponent at the top? 4. The quotient rule says we subtract, and we subtract what's the exponent in the bottom? Negative 3. So it's not just 4 minus 3. Don't make that mistake. It's not 1. It's 4 minus negative 3 in the bottom. And what do you do when you subtract the negative? You add. So that's 5 to the 7th power. And that's a very large number. I'm not going to worry about that. So if you missed that, that's okay. I have expectation that a lot of you did, because subtracting negatives, sometimes we get befuddled. So here's another one. I've got several more examples. Your next one. Let's say that you have a to the negative 3rd over a to the 6th power. Yeah. I'm going to show everybody one way to do things, because but there are other ways. You can. So the question is this, since the cat is out of the bag, so to speak. Another way to approach these problems is if you would like to resolve all the negative exponents first and then just work with positives, that is a fine thing to do. So what she's saying she did is she brought the 5 to the negative 3rd up and applied the applied the product rule. Got the same answer. Okay, just went about it a little bit differently. I'm just trying to show one way at this point, but a lot of you will figure that out on your own, and then you'll realize that. So good question. Thank you for bringing it up. You have a question? Let's do this subtraction. So again, if you wanted to, There's nothing wrong with this. You can bring the a to the negative third down to the bottom, and then in the denominator, you'll have whatever that product rule is. I'm just going to stick with the straightforward using the quotient rule because we have a limited amount of time here, and I can't do all the problems a couple different ways. So I have a to the power in the top is -3 minus the power in the bottom is 6. And you can do this in many less steps, I am sure. I'm just trying to be super clear as I can. -3 minus 6 is -9. And that tells me that the a to the 9th goes to the denominator. Questions, comments, concerns? Here's another one. X to the -8 divided by x to the -5. Right, so again, I'm going to apply the quotient rule. So I have x, the power on the top is -8, minus the power on the bottom is -5. So that is -8 plus 5, that's -3. And that turns out to be 1 over x to the third. So we've done a couple product rule problems. We've done a couple quotient rule problems with negative exponents. Here's a couple of power rule problems with negative exponents. So here's first one, nice and straightforward, very direct problem. 2 to the -3rd raised to the -5th power. Just refresh my memory. The power rule says I do what with my exponents? Multiply them, yes. So I have 2 to the -3rd times -5 is 2 to the 15th. There we go. Here's another power rule problem. Again, we've done every problem we do now, we've already done with positive exponents. Okay, the only difference is some of them are now negative. So here's your next one. Let's say I have 5, and then I have x to the 4th and y to the -3rd. That's all in parentheses, and we're raising that whole thing to the -2 power. What's wrong? They're all separate things. Unless there's parentheses around those two things together, but there's not in this case. All right, so we did a problem just like this earlier with positive exponents. Here was the advice I gave you at that time. On the 5, what's the exponent on the 5 as it's presently written? A 1. So I'm just going to toss that in there. And now I'm going to apply the power rule. So I have 5 to the 1 times -2, which is -2. I have x to the 4 times -2, or -8. And then I have y to the -3 times -2, or +6. The only other thing to do now is to resolve those negative exponents. So here's my fraction bar. The 5 to the -2, where's it going? Bottom. Becomes 5 to the 2nd, 25 if you want to write it that way. The x to the -8, where does it go? It's a negative exponent. So negative exponent has to go bottom. And then the y to the 6th, it's positive, so it stays in the top. There we go. Y to the 6th over 25x to the 8th. I just got 2 more examples of using the 3 properties with the negative exponents. So we're coming up on that time if you have a question. And then after those 2 examples, I've got 1 more topic involving exponents and negative exponents to introduce or remind you of if you've already seen it before somewhere else. Probably, maybe not. So here's another problem. We did a problem just like this before the negative exponents. Now we have them. So I have x to the 5th. I've got y to the negative 2 over x to the 8th, y to the negative 4th. Simplify that, please. That problem right here. But we're divided. So, yes. Same question? Okay. The way you know what rule, in case you're struggling to know where to start, these 2 bases are being divided. So that's, you use the quotient rule. Okay, there's nothing you can do in the top. These bases are different in the top. These bases are different in the bottom. All right, quotient rule. And again, as was mentioned earlier, I'm just going to address it. If you feel like resolving the negative exponents first and moving things around and then applying the rules, that is a wonderful way to approach these problems. Okay, and it works every time, just like my way works every time. So quotient rule, I have x to be 5 minus 8. What's 5 minus 8? And then I have y to be negative 2 minus negative 4. Which negative 2 minus negative 4 is negative 2 plus 4, or 2, just like you all were telling me. Great. Glad you're beating me to the punch there. And so now the x to the negative 3, where does it go? The y to the 2, where does it go? All right, here's our last problem. It's going to look intimidating, but you have done this problem. We're going to do it in 2 steps, 2 halves. So here we go. It says this. I've got 2x squared over y squared, and we're raising that to the 3rd. We've already done a problem exactly like that, just slightly different numbers. And then times 5x to the negative 2 over y raised to the negative 2. So write that down, and then I know it looks intimidating and gross. I get it. So here's what you're going to do. After you've written it down, put your thumb over the right-hand side of it. Don't even worry about it. And just go ahead and take care of this, like we've done before, using the power rule. And then when you've done that, we've done that problem. It's back in your notes. Once you've done that, then put your thumb over that one and apply the power rule to that. Just do each side separate, and then multiply the 2 fractions. And if you don't know how to do that, then we'll do it together in just a minute. Okay, so the one on the left. I'm not gonna worry about this one over here at all, just yet. The one on the left, I put a little 1 on the 2, so I'm gonna apply the power rule. So I have 2 to the 1 times 3 or 3. I have x to the 2 times 3 or 6. I have y to the 2 times 3 or y to the 6. I don't have any negative exponents. We're done so far. Any questions on the left side of this? Please bring them up. The right side of this is going to be the same sort of thing. Again, I'm going to put a 1 on the 5. So I have 5 to the 1 times -2 or -2. I have x to the -2 times -2 or +4. And y to the 1 times -2 or -2. So you have a choice. I mean, there's several choices in this. Don't have the time. What I would do at this point is I would just multiply my fractions. So the way you multiply fractions is you do tops and bottoms. If you wanted to resolve these negative exponents on here before doing that, that is a wonderful choice as well. Okay, so you've got some choices. So I'm just going to go ahead and multiply my tops and bottoms, and then I'm going to resolve the negative exponents. So here we go. When I multiply my tops, remember, we can only multiply things that have the same base. So here we go. Do I have anything that has the same base as this on the top? Nope. X to the 6. Do I have anything that has the same base as this on the top? Yes. So x to the 6 times x to the 4, x to the 10. And then do I have anything that has the same base as the 5 to the -2? No. In the denominator, I have things with the same base that I multiply. Remember, to multiply fractions, you just multiply straight across. Numerators and denominators. That's all I'm doing here. And then in the denominator, y to the 6 times y to the -2 is y to the 6 plus -2 or 4. And I've got one more thing to do and I'm done. And it's a very small thing. If you want to multiply these things out, that's great. The 2 to the 3rd stays in the top. The x to the 10th stays in the top. The 5 to the -2, since that exponent's negative, goes to the bottom. The y to the 4th stays in the bottom. And we're done. So that's negative exponents. That's the properties of exponents along with that. That's the big thing. Okay, I've got one short little thing. We're almost done to finish out our time together. And this is an application of our exponents. This is something that you'll see if you're in any sort of science class. If you've used your calculator and you've got either a really large or really small number, you've already seen this. You might not have known what it was. So we're going to finish off by talking about what's called scientific notation. So what scientific notation is it's a way to write either really, really large numbers or really, really small numbers in a common way so they can either be compared easily or multiplied or divided really easily. So all we're concerned about in this class, we're not concerned about multiplying and dividing or any of that. All we're going to do is to convert numbers into scientific notation and vice versa, just to get used to doing it. Okay, so for instance, if you're taking astronomy and you see, you're told that the distance from the Earth to the sun is 93 million miles. That's a lot of miles. That's a lot of zeros. I don't want to have to keep writing all that down. I want to be able to multiply and divide this number easily. I want to work with it. So we're going to put it in what's called scientific notation. So taking a number from our normal notation and writing it in scientific notation, there's two quick parts to it. So the first part is you're going to write here, you're going to write a number. We're going to reduce this down to a decimal. And the characteristic of the decimal is we're going to write a number that has a number with one non-zero digit to the left of the decimal. That's a lot of words for something that's going to be really simple. Okay, we're going to start off by writing down, we're going to reduce this number to a number that has one non-zero digit to the left of the decimal. Basically, you're going to come at this number from the left and you're going to say, what is the first non-zero number I come to? So what is the first non-zero number my finger is going to hit? 9. So what we're going to do is we're going to reduce this down to the number 9.3. whatever that first non-zero, meaning anything else but zero, whatever that first non-zero number is, that's your digit, 9.3. Then you use x for multiplication. Scientific notation's old school, uses the x for multiplication. And then the second part of this is just going to be the magnitude of the number, meaning how many powers of 10 represent this number. And the way you figure that out is we're going to say, okay, if I'm going to use 9.3, how many places have I moved the decimal from the end of the number where it is now to get between the 9 and the 3? So we're going to have, I'm just going to start here at the end of the number, and we're going to count to the left. 1, 2, 3, 4, 5, 6, 7. We've moved the decimal 7 places, 7 powers of 10. Because remember, we have a decimal system. Each decimal place is another power of 10. So this is 10 to the 7th power. Another way of saying that is you have 9.3 10 millions. That's scientific notation. The question that my class yesterday asked is, hey, Perkster, could I have 2 numbers here to the left of the decimal? Could I have done 93 times 10 to whatever? The answer is no. That's not scientific notation. Okay? The assumption of scientific notation is there's one number here so that you can compare like numbers with like numbers. That's why. So here's one for you. Let's say you're doing something and you come up with this number, 234 and then 9 zeros. I think that's billions. Yes, it is. Write that in scientific notation for me. And then we will end by each writing a number that's really small in scientific notation. And that will be the end of us for today. All right, so what's the decimal I start with? What's the first non-zero number my finger hits? 2. So it's 2.34. You always read the number like you would read any number, just from left to right, and whatever the first non-zero one you come to. 2.34 times 10. How many powers of 10? Yep, great job, excellent. Okay, so that's really big numbers. And again, you've probably seen scientific notation on your scientific calculator when you do some multiplication or division that comes up with more digits than can fit on the screen. So let's say you're in biology class now, and this you measure a cell, and it comes up to be this many millimeters. So I've got a decimal point, and then I've got 6 zeros, 6, 7. So there's a decimal point, there's 6 zeros, 6, 7. Okay, so again, scientific notation, reading the number from left to right. What's the first non-zero digit my finger's going to touch? 6. So you reduce this down to 6.7 times. And now I've got to count the hops. So we go 1, 2, 3, 4, 5, 6, 7 decimal places. But now, since it's a really small number, it's a fractional part. Fractions, remember, are represented by negative exponents. So that's 10 to the negative 7. Now, this is the one time you leave your negative exponents. Usually it's not simplified. You would have to write it as a positive, but with scientific notation, you leave it. Here's your last problem for the day, and then I just got a couple of things to mention about the tests that you have on Tuesday. So here is decimal, then we've got 9 zeros, so it's 3, 6, 7, 8, 9, and then 1, 3, 9. So that decimal place, 9 zeros, and then 1, 3, 9. All right, here goes. What's the first digit I hit? 1. So it's 1.39. Again, I'm just saying this because I just don't want anybody to make a mistake on these things that I'm considering a simple problem, and I want them to be nice, easy points on the test. 13.9 would be wrong. Okay, 139 would be wrong. It's 1.39. That's scientific notation. Times 10. How many decimal places? We counted 10 decimal places, and since it's a fraction, it's -10. That is indeed true. Great job. Let me stop the recording.